Right then, everyone. It's after lunch. Let's have a bit of magic to get you back into it. So I'm Chris Saxon. I'm part of Stephen Feuerstein's Oracle Developer Advocate team. It's my job to help you get the best out of the Oracle database and hopefully have a little bit of fun while doing so. So with that in mind, today I'm going to be doing some SQL magic. Things that look baffling, amazing, impressive that you can do with SQL. But they're not magic really. I'm not a real magician. I'm going to show you how you can do these tricks so you can do your own magic back at work or at home to help build you better, faster, more robust applications. So let's get started. So to start off with, what I'm going to do is a SQL version of a classic magic trick. So I'm sure you've probably all seen the sawing a lady in half trick, where the magician gets their assistant, puts them in some kind of box and seems to saw them into different little chunks. I want to do a SQL version of the same kind of thing. I'm going to take a SQL statement and rip it straight down the middle, and hopefully we'll still have something that works. So just to begin, show there's nothing up my sleeve, no other tables in the schema. We've got a simple query here, just joining the standard employees and departments table together. And we get the output like so. Okay, straightforward so far. So what I want to do is, like I say, I just want to divide it right down the middle, and hopefully we'll still get a statement that does exactly the same thing. So we scroll down a bit here, and if we drag this here, so we got this thing split over two screens. Let's see, we run it again, and yep, still got the same output from this query, even though it's completely different. Now at this point, some of you might be thinking, well, he's probably just hacked the HR table to make it look like this, or something along those lines. So let's query HR employees. We see that, nope, it's still the traditional classic HR table that you all know and love, HR employees table. Okay, so we've divided it into two, but this still looks kind of like a working SQL statement, maybe, right? Let's go a bit further. Let's divide it in half again. So I'm going to go around where it says e.m or something around there. So we scroll that down, split it in half again like this. We're going to run this, and yep, we've still got a working SQL query, giving exactly the same results as we had previously. So what's going on here? Well, you might be thinking, okay, well, maybe he hasn't hacked the HR table, employees table, maybe it's a synonym or a view or something like that. Let's just take a look. There are no other tables views in my schema or in the HR schema. These are just the standards you get when you employ the standard schema. So there really is no table called e.m or something like that. But I want to go further. You might even think that this is potentially still a real SQL statement. Let's go right down so it's just select from and on. So I get this, we just get select from and on, ripped it, so I've completely shredded this SQL statement now. Let's run this, and what do we get? We've still got a working SQL statement. Everything is all hunky-dory, still got the same results exactly as we did at the start. Now, of course, when the magician does this kind of trick, after pulling their assistant into multiple pieces, they have to put them back together again to show that, you know, they haven't really injured their assistant. So let's put it back together again so we can see how it's done. We do that, and what do we find? Well, that's magic. But, of course, it's not magic, really. What's going on here? Has anyone got an idea? Anyone got a suggestion of what I might have done to enable this? What was that? SQL? Rewrite? It's kind of a rewrite, but something else? Any other ideas or suggestions? No, it's not video playback. Nice idea, though. This really is live. I really am doing this. So what I've done is I've used a new feature that came in 12c. It's called the SQL Translation Framework. And what this enables you to do is take a statement that's submitted to your database and execute something completely different. And the way it does this is you set up what are called translation profiles. And within the profiles, you set up mappings from one SQL statement to another. So we can see I have my saw SQL profile here. If I disable that, and we have to enable it in the session with our alter session. So I'll disable that, and as you would expect, you know, that doesn't work. We just get some error or another when we run something that's clearly not a SQL statement. But if I re-enable the saw profile, I get exactly the same results. Because what I've done is I've mapped this query back to that original HR employees join that we had at the start. So some of you might be thinking, well, okay, what's the point of this? You know, it makes for a kind of interesting magic trick. It's a great way to play some practical jokes on your colleagues if you want to get them to return different results. But what's the real practical use of this? Well, before I answer that directly, there's a bit of background. A while ago, a colleague of mine reached out to me. They were working on an application which used SQL Server, and it had this statement in it. And what this does is it generates dates over a period. Now, if you don't, this looks like kind of normal SQL, and if you don't look at it too hard, you might think this is okay. But actually, you need to change pretty much every aspect of this query to get it to run on Oracle database. Date add doesn't exist, convert doesn't exist, get date again. We've got a select here without a from. All of these are things that don't work in Oracle database. And if I try and run this, we get some kind of an error. To get the equivalent statement in Oracle database, you need something a bit like this, where we do the recursive query like so, using sysdate, add months, and so on. Now we get our month's worth of dates. This is assuming, of course, you're on 11.2. Earlier versions, you'd have to do something like the old connect by level trick to get a number of dates. So what the SQL translation framework was introduced to do was to help you migrate applications from other databases to Oracle database. So primarily SQL Server, DB2, and Sybase. So the idea here is you can, instead of having to change the code in your application, what you can do is do this mapping in the database, so the query and the database will do the rewrite for you. So we create our profile called SQL Server, so let's imagine we're doing it, and then we register our translation. So this is the original query that didn't work, and here's the new Oracle version that does work. We stick that in, and now we've got everything set up, but it's not actually ready to go. So everything's there, waiting, but we still need to actually enable it in our session. So we can see that still returns an error. How do we do that? Well, as we saw earlier, you have to set the SQL translation profile to whatever you've called it. So I called it SQL Server up here. You know, call it whatever you want. Use sensible names. Another thing to be aware of, you have to set this slightly cryptic 10.601 event as well in your session. This enables the translation profile. But once we've taken these two steps, let's double check, run this, and we can see, yay, got SQL Server SQL running in an Oracle database. Why? Well, the translation profile has intercepted that and rewritten it to the Oracle equivalent. Now, this is pretty cool, but you might be thinking to yourself, well, typical application has hundreds, maybe even thousands of different SQL statements, right? If you're going to have to go through all of those, figure out whether or not they work on Oracle, if they don't, come up with the Oracle equivalent and register the profile, that's a lot of work, right? You may as well have just rewritten your application anyway, rather than trying to kind of manually do it like this. Well, fortunately, we thought of that. So, as I said, there's a whole bunch of things like get date, select without a from, that don't work in Oracle database. What we've done is we've created these libraries that you can install in the database. So there are a bunch of Java jars that you load in. And when you've done that, Oracle will do the translation for you. So you don't need to come in and manually map every single possible SQL statement. We figure out for you whether it will work or not. And if it does, we'll map it to the Oracle version that we can. So we do that. We enable this SQL translation profile. Let me just switch connection quickly because it's in a different schema. So I do that, and we run get date. Whoop. I need to set the lovely event, as I said I do. So I enabled the profile, didn't set the event. Let's try again. This time I'm actually going to set the event, and whoop, run the wrong thing. We do select get date, and there we go. We've got SQL Server query working on Oracle database. Now, obviously, you might be thinking this can be quite confusing, right? How do you know what really is actually going on in your database? It's all very well as doing this for you, but what if the results are wrong or just not what you expected? How can you debug this? Well, we've got this $mapped SQL view here. So this is one of the dictionary views. If you run that, you can see the SQL text is what is submitted to the database. So we can see we've got select get date there, and we scroll all the way across. We've got select sysdate from Joule. So that's the Oracle equivalent. It's figured out for us what to do and how to get it running. Now, as I said, this is pretty cool, but how many of you have migrated your application from any database to any other database? Doesn't have to be Oracle to SQL Server. So a few of you done it more than once in the past year. Yeah, no. I mean, this is kind of cool and kind of handy, right? But you might be thinking this is kind of limited practical use. And certainly that's a kind of a niche area. But something that's probably more common is performance. Who's had to deal with some kind of slow performance issues in the past year? Yeah, most of us. So sometimes when you've got some SQL statements and they're running slowly, the only way to make meaningful gains and meaningful improvements is to physically rewrite the statement. So for example, instead of accessing the table once, you just list it twice, you just list it once, or something along those lines. So it's all very well and good. You've come up with your new version of your SQL statement, but you might have to wait a long time to get that deployed. Hopefully you've got nice, slick deployment processes and you can get it into production pretty quickly. But what if this is a third-party application? You've got identified a fix for the vendor, but you're waiting on them to actually get it in their patch cycle, release it, get it to you. It could be a long time that you have to wait from identifying some faster SQL and actually getting it into production. This offers you like a temporary fix, a short workaround you can use to get things up and running quickly. This is something that's actually sanctioned by us. There's a line in the docs that says, we recognize you might want to use this to help performance. So, we recognize and understand that. Personally, I would say only use this as a temporary workaround. If you start relying on it all the time, you're going to potentially run into all sorts of crazy issues. So that was the SQL translation framework. It's a way to take a statement that's sent to your database and map it to a different statement. Primarily designed for migrating applications to Oracle, but can also be useful if you've got performance issues, or maybe even odd cases where there's bugs. Is there any questions on this before we move on? Yeah, there's a guy.
Does the SQL must be written exactly? Spaces,
Yep.
lines?
So the question is, does it have to be an exact match? And the answer is yes. It has to match exactly white case, formatting and so on. So if we go back over here, and I just bung some spaces in, let me just double check I've actually gotten the right profile. Yeah, you see it doesn't work. So exact case matching for your statement. Now, of course, if it's coming from your application, you're not going to change your application code that often, or at least you know when you do, hopefully. So it's something to be aware of. Time for one or two more questions. Yeah, go on.
Can we change only part of a query? For example, sysdate to get date to sysdate.
Can you change just part of a query?
Just a keyword, not all query.
So you have to register the complete query with the database. So if you wanted to just replace getDate with sysdate, you still got to submit that complete query in your registration. Now, obviously, you can map that however you want. Basically, what it's doing is it's kind of a layer between you and the database now. It takes that, maps it, if there is a mapping, to whatever you've written. And if you just try and replace one part of it, you get nonsense. So no, it has to be a full replacement of the query. You can't just kind of replace your from clause or something like that. No, it has to be a complete rewrite of the statement. Okay, one more question. Okay, one.
Does it work for procedures as well?
Does it work for, so PL SQL, you mean? You can rewrite, I need to check exactly how it works with procedures, but basically anything that, as I understand it, anything that's a legal SQL or a legal statement you can send to the database, it can rewrite to something else. Okay, so let's move on. Let's go to something different. So I'm going to do something a bit different here. So I've got a table of people here when it comes up, and we're storing various information about them. So their names, date of birth, and their star signs. So those of you who know about these kind of things will be aware that there's a relationship between the day and month of your birth and your star sign. So if you're born in January, as we show here, if you're Capricorn. If you're born in most of October, you're Libra, and so on. So there's a relationship between these two columns. So if you update one, you probably want to change the other at the same time. What I'm going to do is I'm going to update just the birth date column, and the values in the zodiac sign column will change at the same time. Now, classic magician maneuver, there's nothing up my sleeve. There are no triggers on this table, so I'm not using a trigger to do this. Very important thing to be aware of. And it's not a view either. So it is just a regular table that I've built on the database. So we've got the everyone who's a Capricorn at the moment. We're going to change Sally, move her to October, run that, and here we go, ready, and yes, she's changed, and she's now gone to Libra. Okay, so we've updated one. Let's try again. We're going to move Lisa to February, end of February, which I believe is Pisces. So we do that, and hopefully we'll see that, yes, we've also changed that to be Pisces. So as I said, there's no triggers here. I'm updating the value in one column. The other is changing at the same time. And it's not just updates. This works on insert as well. So I'm only specifying the first three columns. If I put a row in for me and query that, we'll see I come in as Capricorn. Now you might think, well, okay, maybe I've just defaulted the value. You know, maybe I've always set it to Capricorn. Well, let's put someone else in. So baby Saxon, born in May, so a different star sign. We run that, and what do we get? They are a Taurus. So I only need to set value in one column, and value in another changes at the same time. What's going on here? Does anyone know? Same thing. What? Translation. No, it's not the same. It's not the same thing as last time. Virtual columns. So a few people know this one there. Yeah. So virtual columns. So if we look at the table definition here, what I've got here, zodiac sign generated always as, and we've got this function. And this figures out, based on the input parameters, what value to show. And this helps solve what I kind of call the classic third normal form dilemma. So if we to build this table traditionally without virtual column, if we do it like this, we've now got a problem, right? Because we've got birth date and zodiac sign. There's a relationship between those, and if we update one, we need to update the other. The way people often can solve this is through triggers. I don't personally advocate that approach, and a lot of people truly hate that approach. I'm not really going to get into the debates around it now, but you could do it with triggers, but a lot of people are kind of opposed to that. So what you really need, but if you're not going to store it, what do you do instead? Well, another approach, you could do what we call classic third normal form normalization. What we really should do is remove this column from the table. So when your date of birth determines the value for zodiac sign. So what we really should do is create this table called dates like this, where we store all the dates and all the zodiac signs for them. Now, this is all kind of nice to say, but actually, you think about the domain, how many dates we need to cover. Let's say this is your simple HR app, and you've got 100, maybe 2,000 employees. They could be born any point in the past 60, 70, maybe even 80 years, depending on how old, when you let people retire at your company. So you're talking tens of thousands, maybe even hundreds of thousands of rows in this dates table. So you've got a lookup table, which is like an order of magnitude larger than the real table, which is, I think there's still a lot going for this approach, but it's a bit weird, isn't it? It's a bit funny. And this is a fairly limited, small example. If you imagine, let's say that your star sign was not only based on the day and month of your birth, but the hour and minute. Suddenly this table is truly colossal, several million rows just to make sure that you've got every combination in case someone new comes along. So there's cases where this isn't feasible. So if you're not going to store it, either directly on the table or the lookup like this, well, what can you do? You've got to calculate it, right? And typically, when you've got a database, more than one application will query that that table. So you might have multiple different applications or just different modules within the application who want to get this zodiac sign value. And in order to ensure that they get the same value, so that you do the calculation in the same way, you want that to be as close to the data as possible. You know, if two different people are writing their own version in their own application, there's a chance that they're going to get out of sync, there'll be bugs in one and the other, and so on. So you can bring it as close to the data as possible by creating a view like this. So you can create the view over the top and do that. So now we are calculating it every time at runtime. And this is, you know, there's something going for this approach, but it does have a couple of downsides. First up, you then need to make sure everyone kind of goes through the view and doesn't access the base table itself. Again, something that's doable, but you need to be, you know, good with your governance, make sure you're reviewing everyone's code and so on to make sure that they only access the view and not the base table. So you need to be on top of things. Also, when you use a view, you don't get some extra information that the virtual column gives you. So when you use a virtual column, you can gather stats on it. So this is useful if you've got queries against the zodiac sign. So you don't want to know everyone who's a Pisces or something like that. By capturing this information, it helps the optimizer get better information, which can lead to better execution plans. Also, if you want, you can create constraints on that. A double check that you've got that function right, so you can't have numbers in there or something like that. So if you've got it as a virtual column, it's part of the table definition. People can't subvert it. They can't come past it and accidentally not query it and think that they need to build their own function. So this is nice. It gives a centralized place to define your functions and ensure everyone reuses them. There are a couple of things you need to be aware of when using this, though. First up, they say it is calculated at runtime, it is generated, so you cannot set it explicitly yourself. So if you try and update virtual column, you'll get an error a bit like this. Same kind of thing applies on insert. You cannot provide a value for it. Our insert will fail, insert, and this also applies if you try and insert null. You can't even insert null like this. We'll still get an exception. It will still fail for us. So this is something to be aware of. Some frameworks and so on can auto-generate inserts and updates and always list every single column. If you've got virtual columns on your tables, you make sure you disable this, otherwise you're going to run into these kind of problems. Another important thing to be aware of, the function must be deterministic. So given the same input, it must always get the same output. Current age, how old you are, is not a deterministic function. Unfortunately, every year we all get a year older, right? So this is going to change over time. If we try and add this to the table, we'll get an exception. It's telling us the function is not deterministic, so it's not allowed. Now, at this point, some people might kind of get a bit creative, because the only way that Oracle knows that a function is deterministic is you providing this deterministic keyword. You know, without this, it assumes it's non-deterministic. With it, it assumes that it is. So we can declare it as non-deterministic, even though it really isn't, just by doing this. So we do that, and we can now add the column to the table. So we've now got that as part of our table definition. Cool, right? Well, take care. Be very careful when doing this. You are now lying to Oracle. You've told it that something is deterministic, which isn't, which can lead to some unexpected results. Let's take a look. So I'm going to index it, that virtual column we created, and I'm going to use this fixed date to fast forward us to the end of the year. So we'll do that, and we'll see we've now Sally's a year older, so she's 43 rather than 42 as she was a second ago. So what's going to happen when I query this? What do you think we're going to see when I query 43 here? Sally? Oh, who votes Sally? And who votes nothing? Oh, lots of votes for nothing. Yep. People voting nothing are right, because the value stored in the index is the value that it had when you created the index. So when you insert it, when you create the index, or when you update values which would change the index, it stores that value. So it doesn't change. The result of the function has changed, but the index still has the old value. If we query when they're 42, we get Quinn back instead. So you can see that by using this telling Oracle that something's deterministic when it's not, you can potentially get incorrect information out of your database. So take great care and be aware of that. Don't lie, basically. This is a good principle in general life, isn't it? Don't lie, but it's particularly important here, or your users might get a bit upset with you. So how do you solve that? How do we keep it close to the data in this situation? Well, the classic old solution, you can create a view. Still has the downsides, but unfortunately, that's what we got to live with for now. Okay, so that was virtual columns. We saw that you define them, and they are calculated at runtime based on other values in the same column. Has anyone got any questions on that before we move on? Yeah, so we got a question up at the top. What about the performance of this? Yeah, so the function is calculated at runtime, so it kind of depends on exactly what your function is doing. You know, something fairly simple like add a day is going to be, you know, there's minimal overhead. But let's say this is a really complicated function where I'm actually doing a whole bunch of mathematical operations. So things like lots of square roots or, you know, something like that. Potentially, it could add some overhead there. So do be aware of that. And in those situations, you might want to store it again. But you'll need to benchmark and test. OK, so we had a question down at the front here.
Can you get Sally by querying 43 if you have a full scan of the index?
If you had a full scan of the index, you would get a full scan of the table, yes. The full table scan hint. Yes, it would stop using the index and it would full scan the table, so you'd read the actual table values rather than the index values. But of course, if you're going to try and do that to stop getting the incorrect results, why have you even created the index in the first place? So, you know, yes, you can, but well, it's important to be aware there are some other functions within the database where this could return incorrect results as well. So Oracle's quite clever about caching function calls. If it sees the same input to the same function within a query, can cache them. So this isn't the only instance. This is just the most obvious instance where you could get incorrect results. Okay. I think one more question before we move on. Anyone? Yeah. I talked about setting. So you mean you have a function with a query to select a value from another table? Well, first thing to be aware of there is that's non-deterministic. So if you've got a query in another table, yes, okay, as long as the data's the same, you'll give you the same result. But as soon as you update that, as soon as you update the value in that table that the query returns that your function is calling, then the function can return something different. So it's actually a non-deterministic thing. So take great care. And back to the performance question, you're then executing that query within the function potentially every time for every row in your result set. When if you wanted to do that, it's probably better to join. You join the two tables together. So yes, you can, but there's a lot of gotchas, and I wouldn't really recommend that. Okay. Okay. There'll be more time for questions later, or feel free to come up to me afterwards. But I'm going to finish up with something a little bit different. So what I've got here is I've got a table of magic dates. I call them magic dates because whoever created this table decided to declare the date column as a number. Now, this is a really bad idea. There's lots of reasons it's bad. Some of the most obvious ones is it allows you to insert things which kind of look like dates and some things which are definitely not. So we've got numbers which are year, month, day format. So we try and insert, you know, 2000, year 2000, who knows what day and month. In it goes, -1, that is clearly in no way a date, but still it goes in. So this is not a good idea. We get those in the table. So what I want to do is I want to convert this number to be a varchar. But I'm going to do it just by issuing DML. So just inserts and selects, no DDL. I'm not going to alter the table. Okay, you ready for this? Okay, before we begin, nothing up my sleeve. I'll set the NLS date format just to kind of prove, that these really are numbers and dates. They do look different. So here we go. So I'm going to start a number in. 1st of January last year, in it goes. Okay, so now this doesn't always work, so I just need to warm up a little bit. Okay, here we go. Ready? All right, and 3, 2, 1, and yes, it's a date. You can see we got it in day, month, year format. Now, as you might be thinking, okay, I did the NLS date formatting, but maybe I still did something to make a number look like a date. No, it really is a date. So if I compare it to dates, we get a row back. If I compare it to numbers, Oracle cannot do that implicit conversion, so we get an exception. It really is a date. So it's gone from a number to being a date. Fantastic. Just with select and insert. There we go. So let's just commit that and move on. So we'll stick another date in, run it, and it's back to being a number again, isn't it? Live demos, right? Okay, let's try again. Let's just check. Yep, it really is a number. It's not a date. Let's check. Is it? No, yeah, it really is a number. So, okay. So, what am I going to do? Let's see. Okay. Let's try again. Okay. Let's try again. I'll start over. Okay, here we go. Let's put a number in. Okay. In it goes. Ready, and 3, 2, 1, and yes. We're back to numbers again. We're back to dates again. Fantastic. There we go. Okay, cool. I think we're back on track. Let's put that in. In it goes. There we go. And back to numbers again. Okay, this is getting silly now. Maybe it's a problem with inserts. Maybe inserts aren't working. What? Well, you've all seen those magic dates. Some dates, instead of using null, people use something like the 31st of December, 1999 to indicate null or unknown or some other kind of magic date. Let's try putting that in. Let's see if that works. So in that goes. And ready. Here we go. Ready. 3, 2, 1, and what? It's now a string. What's going on here? Let's try updates. Okay, something funky with inserts. Let's try an update. Okay, here we go. Last try. Here we go. Ready. By the power of COD, I compel you, become a date, and yes, it's a date. And yep, it's still a date. Still dates go in. Number, that doesn't go in. String doesn't go in. Commit it, save it, and everything's still a date. Fantastic. Thank you. So what's going on?
Well, if the magician counts 3, 2, 1, he's waiting for a job.
No, there's no job. There's no jobs. I promise you, there's no jobs. I heard someone say a view and someone say a trigger. Now, you're both part way to the solution, but there's a bit more to it than that. No, I've already done that one. I can't reuse the same trick. Okay, so what I've done here is I've used a feature that came in 11.2 called addition-based redefinition. Before I explain how it's done, what I'll do is kind of take a step back and explain what EBR, addition-based redefinition, is for. So this is a technology we introduced to help you enable zero downtime releases. Why did we need this? Well, in a traditional Oracle schema, your namespace resolution is just schema name and object name. So in a particular database, in a particular schema, you can only have one copy of a particular object. You can only have one package called customers package, so on. And this is a problem when it comes to deploying changes into production without an outage. Why? Well, in a general case, if you've got your old version of your code and your new version of your code, they might be incompatible. So someone who's using your application before you start your release and using it again just after you've finished your release, things might break. Unexpected things could happen because you've changed how the code works, how the behavior, how it all behaves. Now, There are ways around this. You can start thinking about how you're going to deploy your code, make sure you never make breaking changes, always declare things as with new names and so on. But they're kind of workarounds, they're clunky, and they're tricky to do in practice. You don't stay on top of them. You know, you could do something like every time you release a package, you add a version number to the number end and increment it. So version 1 of the package, version 2 of the package, and so on. So you've always got a new one. But you do that, then everything that calls that depends on that package also has to change. So now you're changing that and all your application code. So that's not great, and a bit of a faff. Also, typically when you do a database release, you change more than one thing. So you do some DDL and some tables, change a couple of packages, procedures, whatever, do some DML, update, insert. From the time your release starts to the time it finishes, your application is in an unknown state. You know, someone who happens to use it, you don't know what's going to happen. Are they getting an error because things are invalid? Or is it going to look like it worked, but it didn't really because some behavior's changed? You don't know. And it's a lot of effort to test and make sure every step of your release works in a safe and repeatable, failable way. And the way to solve this is something that, those of you in the application sphere had for ages. It's basically to create 2 versions of your application, have them side by side. So you've got your live version that your users, your customers are working with, and then you've got your pre-production release or your just to be live version. You deploy your changes to that, make sure that they all work, they're all valid, you didn't release the wrong thing, blah, 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 blah. Everything's fine. And when you're happy that the release has worked, you can then have some process to migrate people from the old version to the new. And of course, if anything's gone wrong, if you realize there's a problem, you either don't migrate them in the first place, or rollback is simply a case of switching them back to the old version of the application. But as I said, we don't have that luxury with the database. You've only got one version of each object in a particular schema. You can do crazy things like create additional schemas, create additional databases, but they're a lot of work which are going to cause you headaches. So EBR was brought in to solve this. And the way it does this is by extending the namespace. So instead of just being schema name.objectName, it is now edition name.schemaname.objectName. What this means is you can have 2 copies of one object in the same schema because they're in different editions. So that's kind of the background. Let's get and have a look at what actually is going on here. So when I've created this, because you've got 3 editions in my database, or a $base, which is the default you'll always have, and then my first 2 releases. Now, I said the edition name extends the namespace. You cannot explicitly specify it. So data type magic is my schema name. If I try and run this, I'll get an exception. It doesn't know. You cannot explicitly ask for an edition name. All of these will fail. So they'll do that. The edition name is implicit in your session settings. So you do it with an alter session set edition. One way to do it is this. So you do that, and we can see the original version of the table with those numbers. We change the edition to E1. We see there it is as dates, and change it to E2. We can see there's all the strings. So we can see each edition has a different version of the table. So how have I done that? How has that worked? Let's have a look at the tables. That's wrong one. So if we bring the table browser up, you'll see that there isn't a table called magic dates or whatever I called it. There's a table called are these dates. So what's that about? Why have I got that? Well, some objects are not editionable. There are still some things you can only have one copy of in a schema in a database. They're primarily things that store data, so tables, indexes, materialized views. So we take a look at this table. So we can't edition the table. We can only have one copy of it. What I've actually got are 3 columns in the table. And on top of that, what I've created are some editioning views. So in my Oracle base edition, we create the view which just selects the column, the original column, the number column. Then I moved into the second edition. It renamed the column selected the second column but renamed it. And then in the third edition, You know, it selected this string, but renamed it back to the old. So this is now transparent to your application. The application is connecting to those views rather than the base tables. So you might be thinking to yourself, okay, so what's special about an additioning view? Why would I use that over a regular view? Well, there's two reasons, two things that special properties of an additioning view. First is that you can only select and rename. You can't have where clauses. You can't have functions in your select and so on. So if I try and do something like this, we get an error. Whatever DML that you could run against the base table, you can also run against the view. So it's transparent to your application. So you're not going to get any weird behavior from that. The other reason is that you can create what called cross-additioning triggers on top of a view. And these are a new type of trigger, and these are the only way you can look forwards or backwards. So if you want to look into a different addition, you would use a cross-addition trigger. So what we've got here, when I'm in that first addition and inserting the number, the trigger is doing a toDate on that and setting that in the column. When I'm inserting a date, it's doing a toNumber to insert it back into the number column. So that's how we got those conversions happening there. So that was a very brief overview to EBR. It's a great tool to help you have zero downtime releases with your applications, but it's only part of the story. The only way to change an addition from a session from one addition to another is within the session itself. So you can't log in as sysdba. Your DBAs can't get in and force things to a new addition. So if you've deployed your changes to the new addition, what you need to do is basically close off all your old sessions and bring up some new ones. So you'd have, you've got your load balancer, whatever you've got on top of that to migrate people from the old edition to the new. So you can now have multiple copies of objects in the same schema. You can go forwards, deploying your changes in a private area, only you can see, make sure everything's working, migrate people onto the new one when you're happy. If you're not, you just, bin it off, delete it, and you can start again if you want. So, any questions on that? Yes, got a question down at the front. Mm-hmm. So that was fixed in 12.1, public synonyms. So you can use it with public synonyms in 12.1. There's actually a number of changes between 11.2 and 12.1. Things like function-based indexes and materialized views, they are not additionable. They could not refer to additionable objects. So you couldn't have a function-based index on your user-defined function. You can do that in 12.1. So there's a lot of changes, kind of enhancements. There's a couple of minor tweaks in 12.2, but the biggest changes are in 12.1. So I think there was another question down in the front.
I know that in 11 version, if you change one schema to additionable and another to not, it is impossible to join tables. It just does not see. You should change all the tables, not only one schema.
So you're saying you should, well, what's your question?
I've changed one schema.
Yep.
Additionable.
Yep.
And then all my joins to another schemas did not work.
I think we'll need to talk about that in a bit more detail later to understand exactly what's going on. But there is a point you do need to enable the schema beforehand. So you actually need to enable a user before you can actually use this feature. So just something to be aware of before you get going. Okay. Anyone else want to ask before we, Camille?
Licensing? Any licensing?
No licensing.
No?
EBR's
Standard edition?
Yeah, part of standard edition. So
Cool.
Anything else? No, well, I'm still around after this for a little while. Feel free to come up and say hi, ask me any further questions. I'm Chris Saxon. I hope you enjoyed this. More importantly, I hope you learned something. Go out and enjoy the rest of the conference. Thanks.